Let's move to the next speaker, which is Sascha Thuler from Umicore. He's a great colleague of mine, so I'm happy to have him on board. Sascha is a chemical engineer by education. He's been working at Umicore for more than 10 years now. He was the responsible head of applied technology for the Umicore fuel cell catalyst, and since 2020, he's now the global manager of sales and applied technology, with the added responsibility for the fuel cells catalyst in the different markets where you can see fuel cells developing. So, Sascha, thank you so much for making the time, and I give you the floor.
Yeah, thanks, Fabrice. Yeah, thanks for giving me the chance to talk to you a little bit about Umicore's contribution in the field of hydrogen and fuel cells. See, blocked. Okay, here we go. So just to give a little bit of a first input, what Umicore is really working on when it comes to hydrogen. So we are one of the major suppliers for fuel cell catalysts. So what we are doing is we are selling fuel cell catalyst powders for PEM fuel cells and PEM electrolyzers. And when you just look at the materials that are used in PEM fuel cells and PEM electrolyzers today, most of you know that these are all based on precious metals, specifically here platinum and iridium. So therefore, another service that Umicore is offering, and that's also a part of the research work that is to be done in Umicore, is to think about how you can recycle end-of-life stacks, MEAs, and also production scraps that occurs during the production of these systems. To illustrate that a little bit more, you can have a look at this scheme. Yeah, you'll see it all starts for us with the catalyst powder. This is then sold and handed over to a company who's making this electrodes and the membrane electrode assemblies. These are then assembled to stacks, and these stacks are then integrated into the system. So when you look at that, it's a quite complex supply chain, and of course, our materials need to be designed in a manner that they achieve good performance and durability in connection with all the other components and under the operation conditions that these systems are then going through over their lifetime. For most people, it's a little bit untouchy to what these powders are, but at the bottom you can see a little bit of a picture. So we are offering powders, and these powders, when you really zoom in with specific microscopes, you will see that all these powders are based on a support, and on the support you have the precious metal being there as nanoparticles with a diameter in the range of below 10 nanometer. And these catalysts are used on the anode side and on the cathode side for PEM electrolyzers and PEM fuel cells. And there are different types of catalysts. So the main catalyst type today is platinum on carbon. This is used in PEM fuel cells and PEM electrolyzers. Some companies are using alloy particles, so platinum cobalt alloy catalysts in fuel cells. And then, of course, one major part of the iridium oxide demand in fuel cells and electrolyzers is on the anode application in PEM electrolysis, because here iridium has been shown to be the most active and most durable material. These powders, when you just look at the composition, they have a very high precious metal content. So all these powders we are selling have a minimum precious metal content of 2-digit weight percent. And with that, I would just show you a little bit about what Umicore is actually working on and how we are positioned. So Umicore started already 30 years ago to work on fuel cell catalyst powders. And right now we have a long and good footprint in the industry. That means for our supply base, we can really say that we are globally active and we are present in globally operated PEM electrolyzers and PEM fuel cells. The key markets, as you know, at the moment are mainly the car and truck companies that are really working on fuel cell deployment. And for these materials from Umicore are really considered as benchmark catalysts. And when you look into the scientific world, you will find a lot of publications where people used catalysts from Umicore to support their research work. A major part of our business model is, of course, research. And our research is located in Germany, close to Frankfurt, and in Korea. And right now, when we talk about maturity and the market, so we already producing this catalyst at mass production level. So that means we are already active in this market. And at the beginning, you said, we are just at the beginning of the whole hydrogen economy. So that means for Umicore, the challenge really is to supply the materials our customers need. And this, of course, comes with significant investments in production capacity to cover the demands. From our perspective, talking about a little bit the associations and our presence. So we are a member of Hydrogen Europe and of the Hydrogen Council, and we are continuously supporting the industry and anybody in the H2 environment with our knowledge and know-how to really promote the deployment of hydrogen and the deployment of fuel cells and electrolyzers. Good. Looking a little bit into the market, that you get an understanding what this all looks like from our perspective today. So I know the trend for fuel cell applications in motive applications, it really changed over the years. And at the moment, it really looks like that there will be a future for PEM fuel cells in motive applications. But this will definitely move and focus on commercial vehicles, since for the PES car applications, when we really talk about light-duty passenger cars, the battery clearly won the race from our perspective. But there are niche applications where fuel cells can make a difference, and this is everywhere where you have long driving distances per day and where you need to transport heavy payloads. So simply speaking, fuel cells can make a difference in fleet operations, taxis, delivery vans. That's where we still see a need for light-duty fuel cell vehicles. And when we look at the map, you see that markets are the developed countries like in Asia, Korea, Japan, China, in Europe, the European Union, but of course not exclusively, only the European Union. And then we have North America, where we also see a big market ramping up and developing for this kind of applications. I think you all know why that is happening. It's all because we have the global legislation that is really now pushing for CO2 reductions, and the fuel cells really offer the solution to transport goods at high efficiencies and with a low carbon footprint. Last point for that slide, that you get a number. So what we are seeing is that the market for the fuel cell catalysts will reach a 3-digit tons per year scale. And when you then consider that this material contain precious metals, it's clear that we need pay a lot of attention and a lot of investments in that to make that really viable, because without the catalyst materials, the number of trucks cannot be deployed that are needed. Another important factor for us, and I think for the whole industry, and you also mentioned that, is of course the supply of hydrogen. So for us, it's important, first of all, that hydrogen is available. And I think we are all agreeing that the green hydrogen is the best solution. But there, I think we need significant investments over the next years to get that really being available. And secondly, it's important that we get that being available at low costs, because for the industry, specifically for commercial fleet operators, they are all focusing on total cost of ownership. This is called TCO. And I think a good way how you can always compare the fueling price at the dispenser of diesel and hydrogen is if you make that calculation on total cost of ownership parity. And I think from the studies I've seen, there's a high chance that we can reach this total cost of ownership parity in the course of this decade. And then I think, yeah, the deployment and the mass market production rates will definitely go up, because then there is no con mehr for the industry or for the fleet operators to use it. Yeah, I think there's a lot of work in the Hydrogen Council. I just illustrated that to give you a few ideas. Yeah, so you see that the green hydrogen production capacity, we have the significant investments already. You see that the price for green hydrogen is also seen to be in a reasonable range. Yeah, and I think then the final stage that everybody needs to take care for is really to check how do we get the hydrogen transported to the dispensers and to the consumers. We see it that way, that at the moment everybody is trying to install and being ready to install, let's call it a backbone infrastructure along major transport corridors. And then after 2030, yeah, this whole network will be optimized, and you will just get linked interactions between the different pipeline systems, for example. And if we have reached that, yeah, I think then the whole industry is working, and we can be looking into a green future for the commercial transportation sector. So, of course, this here is a little bit about the development trends and what we see as needs. So I think the industry is really at the beginning, and I think over the next few years, there's definitely a lot of work to be done to bring down the system costs. Yeah, and when we talk about system costs, it's not only about the catalyst precious metal content, which is of course also important, but I think most of the cost-saving potentials are really in the economy of scales for all the different components that are used in such a complex system like a drivetrain or an electrolyzer systems. We will definitely get a lot of information from learnings we make from the first fleets and the first electrolyzers that are operating in the field. And finally, everybody needs to exchange that experiences that the whole industry is looking for, a minimization of the iridium and platinum amounts that are used in the systems. And what can Umicore do? What are we doing? Yeah, so we are definitely continuously working on the improvement of our catalyst technologies. So that's really the powder properties, you can say, but there's a lot of research also necessary really on the process design and the production technology that you are using to make the catalyst and to handle the catalysts. And I think when we just combine these two in a research and innovation package, this is then all contributing to this cost reduction to make the future systems more affordable than they are, for example, today. The second part at the bottom, you see recycling is also a major topic for Umicore and the whole industry. So I think the target must be that you have the highest possible PGM recovery rates. This is especially true for Europe, where we don't have any precious metal mines or any sources where we can get it from. And right now, one must admit that there is no recycling ecosystem. So that means nobody really knows how will the end-of-life products, how will they end up at the recycling facilities. So I think this is one of the major fields where the industry and also academia and the governments can work together to make that happen. And Umicore is really available for being a good partner in that field, with our recycling know-how, since we are already recycling, or we do recycling of the MEAs, for example. And I think we can also contribute with our process design and engineering know-how for that kind of applications. To give you a little bit of an illustration how Umicore is doing that and how we are just working on the improvement of our catalysts. So you can see that there is a clear roadmap for Umicore, with different development milestones, where we really then inject new technologies into the market. And all these technologies are really focusing on the reduction of the precious metal loading of the fuel cell. So that does not automatically mean that we reduce the precious metal content of our powders, but the precious metal content in the final electrode. That's the decisive part of that. And that should of course then come with, on the one hand side, the saving in the precious metal content and or the precious metal usage, and then of course also the processing costs that we can improve. We do that in an open innovation process. So you can see that we are, have a good network with research institutes and partners all over the world. So here in Europe and the US and also in Korea. And I think this is also one of the strengths of Europe, that this research is really available and that we really have the know-how, how you do testing, how you design MEAs, and how you then finally really know what the key differentiators for powders and systems are to be a competitive country or region for the fuel cell industry. Good. To sum it all up, as I mentioned, so we are offering a competitive catalyst portfolio for PEM fuel cells and electrolyzers already today. I think PEM technology has reached a stage where it's really ready to scale up. And now it's really a question of scaling it up, doing the massive investments in the supply chain. And our part as Umicore here is really to be a reliable and responsible partner who can really then be a good supplier for the whole industry. That includes the PGM handling, what is also very important when you think about tons of iridium and platinum that need to be handled and processed. It's about the catalyst production and the different regions where the people will set up their production lines for the fuel cell systems. And of course, we will there rely on our experience as an automotive industry supplier, and of course also our existing footprint that we already have worldwide when we talk about production facilities. Good. As I mentioned, we are ready to help to develop and install a closed loop precious metal model for the industry. And secondly, finally, we will just continue working on the catalyst property improvements, and we will try to improve our production processes. And it's all then targeting for the higher PGMs utilization and the production cost reduction. So that's all I had. So thanks for your attention, and I'm open for taking your questions. Thank you.
Thank you so much, Sasha. It was a very rich presentation. I have one question for you that is in the Q&A. It's a question dealing with, I would say, collection. It comes from Mrs. Marchisio from Ernstel Recycling in Germany. And the issue that they see, and that we often see also, for example, for batteries, is the issue of collection. So the logistical elements of the closed loop. How do you think that we could improve this collection? That's a question that we would like to ask you.
So we are, as Umicore, we have the same issue. So we are also at the end of the pipeline, I would say. And I think this is a major challenge for everybody in the industry who's deploying the systems. And I learned that some companies are already thinking about owning the stacks and not selling them to anybody, so that they make sure that they are really have the hands on the systems before they at the end of life. Then there are other options where people think about refurbishment of stacks. So there might be dedicated companies who are then doing the refurbishment of stacks. But finally, as I said, we need to work on that, because at the moment, I haven't seen any really conclusive approach, even not, I think, a real legislation that is forcing people to recycle the stacks. So there's a lot of work and a lot of discussions we need to take to make that happen.
Point taken. So we have a lot of work on our hands, not just materials, also that. So for the sake of time, since we are running late, I would thank Sasha so much for making the time.